What is a JWT? A JWT is a JSON Web Token. Right, now we've said that, we haven't actually moved the subject on that much. Let's explore together what a JWT is used for, how a JWT is structured, and also how JWTs allows us to design stateless servers. But first, what is a JWT for? To understand the point of JWTs, you have to understand the problem they're trying to solve. Imagine you're a server waiting patiently in a rack in a data center, and you received a message that says, show me the homepage, or to speak HTTP, a get/index request. You generate the homepage and send it back. So far, so good. Now imagine that on the homepage, you've been instructed by your programmer overlords to display the first name of the person who requested the page if they're logged in. Or imagine that the person is requesting another page such as /secret, and you know that this page is for employees only or reserved for those who've subscribed. How do you handle that from the server's point of view? To state things differently, how, when the server receives a message, does it know who sent it? Sure, at some point, the user logged in. He or she entered an email and password, so we the server, knew then who it was. When the server receives a message on /login with an email and password, it checks the database that the email and the passwords match, and it returns an error if they don't. But let's imagine that this message to /login was sent, say, 10 minutes ago. Let's imagine there are hundreds of people, each with different rights, who are also logging in. How does a server know that this message or request is from that user? This is where request headers come in. We can put information in them. We could add the user's email to identify them, but that would be trivial to spoof. We could add the passwords, but that would imply two things. First, the database would have to be checked every time a request is received, which is costly. Second, the password would need to be sent in each and every message, which is risky. Clearly, this isn't ideal. A first solution, the solution that's been used for a long time, is to create a temporary password, a secret, that the user receives as a response when they log in. The server remembers the link between this server and that user, and when the browser talks to the server, it sends this secret via the request headers. Then the server, when it receives the message, checks in its memory if the server corresponds to a user. This secret is what is called the session. This secret is what's called the session identifier. All this works fine when you have one single server. But imagine that you're managing an application with hundreds of servers, and in front of these servers there's a load balancer which sends messages to the servers that are less used. So when a message arrives, there's little chance that it will be in the same server as the one used for the login. So we can't rely on the server keeping the secrets in memory. We can create a central database, possibly in memory, but it would be much better if we could make our servers stateless. That is to say, able to process requests without having to keep a state in memory between requests. If we could do that, it would allow much easier scalability because there would be no need to communicate a shared state between servers, and that is where the JWT comes in. The JWT, or JSON Web Token, moves the problem. It's no longer the server that manages the state, it's this token that contains it. How does that work? Well, let's see how a JWT is built. A JWT looks like this gibberish hodgepodge of letters and numbers that you can see on the screen. As you can see, if you look carefully, there are 3 blocks of text separated by dots. These blocks are the 3 parts of the JWT, namely the header, the body, and the signature. Each of the parts is encoded in base 64, not for security purposes, but to allow the token to transit peacefully via an HTTP message. Now let's have a look at these 3 parts. First, the header. It specifies the algorithm used for the signature with the ALG, the ALG field, meaning algorithm. Here in this example, the HS256 indicates that the token is supposed to be signed with a key in SHA 256. The second part, the body, contains the claims. This here too is a JSON document. This is what the token states, for example, which user the token belongs to, the ID, the rights. We can, and if we want to do this right, we must specify the creation and expiration dates of the token. The JWT standard specifies the names of these fields. For example, the EXP field specifies the timestamp of expiration, which is the number of seconds since epoch, that's 1st of January 1970. So a non-base 64 version might look something like this, with the ID 42, name code apps, role admin, and expiration date with a timestamp. Now, this body is the part that stores the state and allows the server to work in a stateless way. Finally comes the cryptographic signature. This is the part that allows us to validate the token. The idea is for the token to be signed with a secret that only the server knows. That way, if the signature matches the secret, I, the server, know that I can trust this token and its claims without needing to consult a database. JWT's first advantage then is that it allows the servers to be stateless. That is to say, without needing to store any state in their own memory. The second advantage is that JWTs can be used in the context of mobile applications where cookies or sessions make less sense, or in the context of communication with an API, where in the same way sessions don't really exist. A third advantage is that using an asymmetric key pair, a token signed with a private key can be validated by anyone who has the public key. So this means that a central body, one which we know to be trustworthy, can issue a verifiable certificate, which states, for example, this user has these characteristics, and you can verify with this public key that I published that his JWT token is valid. And now it's not only the emitting server that can validate this certificate, but anyone who has access to the public key. So in summary, a JWT is an object with a cryptographic signature, which encapsulates a state which is expressed as claims. Depending on the algorithm that's used, the token can be validated by the server itself, and this is useful in the case of an application or an API calls or in stateless servers. And in using a private public key pair gives us the means to set up a trusted third-party mechanisms. JWTs are not always preferable to sessions. They do have some drawbacks, such as adding to the message size, but in the right situation, they can be very useful. And another thing that can be very useful is continuing on your journey to learn. So feel free to click on this video here, and to learn more about web development and development in general. Thanks.